And like a damn Freemason, I'll run this nation.
Welcome to Chip Logic Studio, and in this video we will study about event regions in Verilog and SystemVerilog. So without any delay, let's start. So first we should know why we are studying the event regions, because event regions are related to your execution orders. So your first is your execution order must be there, because it is your hardware language. It can run parallel, sometimes it can run sequential, sometimes not, like your programming language. So some order execution must be there, that it compiler doesn't get confused. So first of all, this thing is related to compiler, you can say, because every coding language depends on compiler. So you can say the execution order should be defined, and avoid race around condition, because you are defining hardware. So for example, if you are defining latches, so it should not have your race around condition for that. So synthesis should be proper. This will be your separate video. After this video I will create this video for blocking, non-blocking. So before that I am completing your event region. So this is very important topic. And next is your model hardware behavior. As I said earlier, the hardware behavior should be mimic your exact behavior of your hardware. So we need some execution order for that. Synchronization of DOT and testbench, because DOT and testbench are synchronized with single clock, and there are some regions and there are some directions between DOT and testbench. So some synchronization need between your DOT and testbench, how they both will execute. And enable verification features. So we have some features in SV. We will see this whole part is our assertion, coverage and clocking blocks. So for that we will see our Verilog, and we will know this. Support 0 to low, we will know this after 2 slides. And provide multiple hooks. Testbench can drive and react correct times without correcting the duty, because they both are executed simultaneously. There should be some specific order for execution, so it cannot interfere with your duty. So important points are your blocking, non-blocking. We are studying for that. And avoid race around condition, defining some execution order. There should be some specific order rules for execution. And these our SV concepts, which are most important for our verification. Without this we cannot verify anything. So let's see without any delay. So as you can understand this with you can understand, like, there is passage of clock and we are executing some signals. So some will execute in this part, some will execute in this part, some will execute in this. So we are dividing some slots, that at which slot the some execution statements will execute. So simple logic is there, that we have defined some execution regions, which we are saying event regions, and divided into ordered regions. As you can see here, divided into some ordered regions. So we will know that at what time it will execute, and it will not interfere with other. Simple logic. And now logic is that this block will start, and after all completion of region we will go for our next block. So between them there are 4 regions: active region, inactive region, enemy region, and monitor region or postponed region. Mostly we will call this a monitor region in Verilog. And before that also there is preponed region, but mostly we don't consider it. We directly say that there are only 4 regions. So only stick to your 4 regions. If someone asks you that there is preponed region, you can say there is, but it has no importance in for now. So these 4 regions we need, that active region, inactive region, NB region, our postponed region. And we will see these regions one by one. So we will only understand that what execution statements are or blocks are executed in specific regions, and this is all our concept about event region. Simple concepts. Our initial block, always block, and with that module, program block, all these block execute in our active region. And blocking assignment, LHS as well as our RHS is executed in our active region. And continuous assignment, assign block, is also executed in this region. RHS, this is the most important point between blocking, non-blocking. So for example, if it is 1, for your example, our RHS is 1. So RHS will execute in active region, and LHS will execute in your NB region, which is our third region. So we will wait for this statement, and this will execute. So this is most important concept for your sequential circuits. We use mostly our non-blocking assignment, because of this behaves like a sequential circuit. You can say it gives us behavior of sequential circuit, and this gives us behavior of combination circuit for most of the time. So you learn this, that RHS of our non-blocking region will execute in active region. Primitive updates like and nmos and every primitives like ragewire, because we should know the value of all them before our next region. So these primitives will execute in next region. Events, we will if you want I can make separate video for that, so comment me about if you want your event any video about that. And most of the things will execute in active region, so don't get confused about that. If you don't know that which region other things are executed, just say that it is executed in your active region. For example, task can function also execute in this region. So simple things. Now in active region we want that our active region execute, and then we want some statement to execute our inactive region, so we will have our hash zero delay. If for example if you have given this hash zero delay to any statement, so after active region it will execute, and we will get what we wanted, that after all the statements should execute, and then we will get our hash zero delay. So this is that. And reschedule, that the same thing that we were rescheduling, that we don't want our statement to run on our active region. There might be some cases. So for now you can understand that whenever we use hash zero delay, the statement will execute on our inactive region. And most important thing, like dollar display and dollar write is our system task, and this statement if you use it will execute in our active region. So whatever statements in active region, then only you can see the values of that statements in your dollar display and dollar write. Otherwise it will just give its default value, and for example if has zero delay is there and some statement is like a equal to b or equal to 1, something like this. So it is at has zero delay, so its value a and b value will be, for example if we are declared it range, so a or b value will be x by default, and dollar display will give your x, or dollar write also will give your x. And in inactive region if you have to use dollar monitor, which will be executed in monitor region, so it will give you a proper value. So this concept is follow that wise, so your compiler also execute in different region. So we will understand more about this dollar display dollar write in blocking non-blocking. Our non-blocking assignment, our b equal to 1 we have taken the example. So when we get RHS we get in our active region, and LHS we will get in our NB region. So LHS updates our non-blocking assignment in this region. Answer value calculated in active region update single letter and payment traces. So this mostly we use for as I said earlier, sequential circuit for race around conditions. And last is our postponed monitor region. So like dollar stop and dollar monitor as similar to our dollar display and dollar write, but the different thing is that dollar stop will give you a final value, and monitor will give whenever the sensitivity has changes. For example it changes from x to 1 as our previous example, first default value x then changes to 1, so it will give you two statements. It will give our dollar monitor, first update is x, second this is 1, execute after all the updates is current time short. So this is last region, so it will give you final regions and every last update of your whatever statement you have written. So this is about Verilog. Now similar to your Verilog, your system Verilog also start with your this cycle and go for the next cycle, and between them there is some 7 regions. And active region similar to your Verilog, inactive region also similar, NBA region also similar. These two regions are new, that is your observed region, reactive region, re-inactive, re-NBA, and postponed region. So postponed region is also same as monitor region, but only these 3 regions are your new regions in system Verilog, and we will see that one by one. So preponed region, as I said earlier, there is one preponed region here. There is some preponed region here, but we mostly don't assume that, we directly go for active regions. So preponed region execute before simulation time, means it just samples the data. Means for example if there is 1 2 as a equal to 1 or b equal to 2, so it samples that 1 or 2 will be there. So like it's preparation before execution of some regions, something like this. You can understand that it will prepare before the clock cycle that these things are there. Now our main thing is our active region. So similar to our previous, our Verilog active region is similar to that, so I will not take more time in active region. Inactive region also same, and NB region also same, so I will also not take much time in this part. So you can see that same things are there. observed reason. So a separate video for assertions, so you have understand that what assertion concepts are. So these assertion concepts are executed in observed region, therefore it is some different concept. So we have given it a different region for assignment, and it has some different tasks also, like verification tasks are there. So observed region will execute your assertion samples value and allows temporal assertion to observe the stable value. So for example, immediate assertion you have written, so it will execute in this region. In reactive region, program block is our new block introduced by SystemVerilog program block. So this program block execute in reactive region, and mostly for this block we have created this reactive region for avoiding some race around conditions and meta stability state for timing, based on timing analysis, you can say, based on timing. So these are all the reasons.